Welcome to Unit 3.3, My Brain, My Mind. I'm Diana Lindsay. When I was diagnosed with cancer, the odds of living 5 years were 1%. So how do I get into the 1% club, I thought? It would require a drastic change in mindset, the ability to think otherwise, to be completely open to life and its possibilities. Because to be in the 1% club, I needed to be willing to seek out, try, and benefit from what 99 out of 100 would not. But to do that, I would need humility. I would have to abandon 99% of what I thought I knew about healing and accept that I only knew 1% of what I needed to know. But how do you let go of what you know? How do you face the void of that unknown 99%? Where in my brain were those centers of healing? I did think it was a place in my brain, so I practiced releasing the hold of my left brain in order to explore the right. I knew that my right brain was where my creative centers were, and I hoped it's where my healing centers were. But maybe it wasn't a place. Maybe it was a frequency, like a radio station that I had to learn to dial into. I became fascinated by the brain, this extraordinary brain that James Watson, the Nobel Prize winner for the discovery of DNA, said was the most complex thing we've yet discovered in the universe. It has 100 billion cells, each of which connects and communicates with up to 10,000 collaborators, forging a network of some 1 quadrillion connections. It was formed by evolution. We began with the reptilian brain, evolved an emotional brain called the limbic, and then a thinking brain called the neocortex. Each of those contributed different capabilities. The reptilian brain helps us survive, react, repeat. The midbrain or limbic helped us feel, to remember, to interact with others. And the neocortex has given us the capacity to talk and think, to move, create, and learn. What we don't recognize is that our brains are also formed by our bodies when we're young. A man named Wilbur Penfield figured this out in 1930 when he mapped the brain of patients he was doing surgery on by inserting probes into it and asking the patient where it was a she, in this case, felt sensation. On the left of the screen is the somatosensory area, a body map based on touch and related sensation. And on the right is your primary motor area for your volunteer movement. Now, what was interesting in Penfield's study was that the proportion in the brain is directly proportional to how our body functions. So you can see that in our sensory system, our lips and mouth and our hands are huge. They're even huger in the motor system, which is really interesting. These sculptures are from the Natural History Museum in London. Your body is your mind's true foundation, says Sandra Blakesley and Matthew Blakesley in a really fascinating book called The Body Has a Mind of Its Own. They say you can think of the maps as a mandala whose overall pattern creates your embodied feeling self. All of your other mental faculties, vision, hearing, language, memory, hang supported in the matrix of the body mandala, like organs on a skeleton. Blakesley goes on to say how this works. So one experiment was done with small animals, like a kitten. So if you carried a kitten during its critical early months of brain development, allowing it to see everything in its environment, but never permitting it to move around on its own, the unlucky creature would turn out effectively blind for life. This understanding has led to a whole field of research called embodied cognition, and it's yielded surprising results. If you put a pencil between your teeth, in the back part of your teeth, it will force you to smile, to use the same muscles as a smile. And in the process, it will make you think better about anything that is put in front of you. If you put that same pencil between your lips, using the same muscles as a frown, you will think less of whatever comes next. A second study was fun. This had to do with a prompt of guilt, making you feel guilty about something. Afterwards, you were more likely to go in and wash your hands for longer. Another study had people get inoculated after a flu virus and then hand them a questionnaire about how they felt about immigration control. Those that were inoculated against, quote, strangers showed greater leniency than those who were not. The one that you can see in any group is if you give someone a warm cup of coffee, it'll make their first impressions of people warmer. My personal favorite from this field is a study of in-the-box thinking, literally. They force people to sit in a box or freely roam around. Afterwards, they gave them a standard creativity test, and those that had been in the box had fewer creative solutions than those that had been able to wander freely around. Teachers, artists, and parents, take note. Now, we do have two hemispheres in our brains, called informally the left and right brains, which you've probably read about in the popular press. The left brain is sequential, literal, functional, textual, and analytic. This is the side of the brain that we will often identify with as our rational minds. The right brain is simultaneous, metaphorical, aesthetic, contextual, and synthetic. Now, when this research first came out, people enjoyed identifying themselves as, I'm left brain, I'm right brain. But of course, it's not as simple as all of that. There were three thinkers that influenced me in my decision to move more from my left and into my right, simply to see if I could find within there the centers of healing. These were Andrew Weil and his book Spontaneous Healing that first introduced me to the concept of mind-body healing. A Whole New Mind by Daniel Pink is a wonderful exposition of the advantages of both systems and how we can cultivate both. And then Jill Bolte Taylor has the profound video that's been seen so many times, millions of times. And as your assignment at the end of this module, we'll ask you to watch it. Now, the other way that people have identified the different parts of the brain is between our conscious and our unconscious. People make decisions before giving conscious thought. We all experience this in our cars when we drive home without even really remembering the last 5 minutes of our drives. But it also affects how we vote. New research shows that competency ratings based on seeing the candidates' faces for less time than it takes to blink an eye predicted the outcome of 2 out of 3 elections. This was just published in January of this year. This is a fun one. Men who were attracted to women found that they were attracted to women based on a 2 millimeter difference in the dilation of their pupil, a fact, of course, they were not aware of. So who was doing the choosing? The men didn't know that the choice was not theirs really, but instead the choice of successful programs that had been burned deep into the brain circuitry over the course of hundreds of thousands of generations. This kind of unconscious information guiding conscious choice has been shown to be affected by other things in the environment, not only by these old programs. This is called priming. So take a look at these. Now, if I say the word eat, how do you fill in this? And how does that change if I say the word wash? This has started a large field because you can imagine that that word eat, you could also be primes of lots of things: fork, hungry, fat, diet, cookie, and a whole range of emotions maybe from your own past. A classic experiment was done by John Barg at NYU. Students between the ages of 18 to 22 assembled 4-word sentences from 5 words, like you can see here: find, see, it, yellow, instantly, and perhaps you did that as I did. He He finds yellow instantly, or he finds it instantly. But they divided the group into two, and half of the group, they interspersed words like these: Florida, forgetful, bald, gray, and wrinkled. The point of the experiment was not how they formed the sentences, but what they did after. They walked to another room, and the researchers measured how long it took them to do that. The group that were primed with Florida, forgetful, bald, gray, and wrinkle walked slower than the group that had other words. This, too, happens without any awareness. The students insisted that they didn't even notice these words and that they did nothing differently. This priming effect is profound, and it is everywhere. If a minority student checks a box labeling him or her before a test, he will do less well. If preschool girls at Harvard daycare are reminded they are female and have to check that off, they do less well in a simple math test. Your consciousness is like a tiny stowaway on a transatlantic steamship, taking credit for the journey without acknowledging the massive engineering underfoot, said David Eagleman in another fun book to read called Incognito. Now, Daniel Kahneman, a recent bestseller about thinking called Thinking Fast and Slow, was written by Daniel Kahneman, a Nobel Prize winner in economics, who was very interested in how people made personal economic decisions, and how that in fact influenced all the decisions they made. He didn't look at it from a strictly anatomical point of view, but rather from the systems point of view of how our minds work. He called that simply System 1 and System 2. System 1 is composed of our impressions, our intuitions, intentions, and feelings. And it's generally very good at what it does, he says. Its models of familiar situations are accurate, its short-term predictions are usually accurate as well, and its initial reactions to challenges are swift and generally appropriate. System 2 governs our beliefs, our actions, and our questions. It is what we would normally call our more rational mind. System 2 is who we think we are, he says. It articulates judgments and makes choices. It prevents many foolish thoughts and inappropriate impulses from overt expression. So how does this professor at Harvard grade these two systems? Well, System 1 is subject to predictable bias and cognitive illusions. It substitutes what it knows for what is asked. It's overconfident, has extreme predictions, and planning fallacy. Well, how about System 2? Well, it's not a paragon of rationality either. Its abilities are limited, and so is the knowledge to which it has access. And what's more, it's a lazy controller. Whenever you put high demands on System 2, when you make too many decisions, when you get low glucose levels, when you exert too much self-control or inhibit your emotions or try to impress others, you feel unpleasant in your body. We seem to have a given quantity in each day of how much we can exert this kind of self-control. And when we depleted it, we deviate from our diets, we overspend, we react aggressively, we persist less time on difficult tests, and we perform poorly in cognitive tests. This effort has shown to deplete glucose, leading to sometimes scary and disturbing results. Researchers recently followed 8 parole judges in Israel. The default decision to deny parole over the course of a day was 35%. But researchers were able to correlate these decisions with the timing of the judges' food breaks. 65% of requests are granted after a meal and then drop steadily to 0 before the next meal. Tired judges go back to default mode, and so do tired parents. So we have a team of rivals in our brains: left, right, conscious, unconscious, reptilian, limbic, neocortex, and it not only drives us crazy, they can result in an inaccurate view of the world and the choices we should make. Isn't this freeing to know? You and I are not the only ones. This is the human condition, and it's great to not take ourselves too seriously. Václav Havel said, "Isn't it the moment of most profound doubt that gives birth to new certainties? Perhaps hopelessness is the very soil that nourishes human hope. Perhaps one could never find sense in life without first experiencing absurdity." The good news is we are built to learn. Our brains are dynamic, plastic, even as we age. This is called neuroplasticity, and the book that introduced me to these exciting and extraordinary ideas is The Brain That Changes Itself. There are two principles in a cool research that got us going here. Neurons that fire together wire together. This wiring leads to habitual behavior. Judging by old movies, a whole generation wired sex and cigarettes together. But fear not, the second principle is use it or lose it. Somewhere, current generations lost that association, and that's why we see movies where the actors reach for their iPhones after sex instead. The research that inspired me was Dr. Hangjin Sun, an assistant professor of neurology at Johns Hopkins. It's not the age of the brain, but the age of the neuron that matters. We have 2 weeks to lodge a new neuron, he said. So take this idea of consolidating a habit by taking the Qigong exercise we've given you in Healthy Body and try to really make it stick in the next 2 weeks. Deutsch takes all of this information and realized that neuroplasticity impacts not only our behaviors, but our genes. Thinking, learning, and acting can turn our genes on or off, thus shaping our brain anatomy and our behavior. Surely one of the most extraordinary discoveries of the 20th century. Now, coming back to my story, what about this idea I had about the frequency of how our brain works, like the radio station? Is that possible? It turned out yes. We do function at 5 different frequencies. Gamma waves, which gives us a hyperbrain activity, which is great for learning and is also, interestingly, what Buddhist monks use. Beta waves, where we busily engage in activities and conversation. Alpha waves, where we're relaxed and we can deepen into a meditation, also where we daydream. Theta waves, where we get drowsy and drift down into sleep and dreams, but also where we can do more active imagery. And delta, where we sleep and don't dream. Now, we've seen how the body helped form the brain. We've seen how our conscious brain, what we used to call our mind, is but the tip of the iceberg, that our unconscious minds are more pervasive and powerful than we thought. And we've learned how our environment primes our thinking in ways we are unaware of, bringing questions to my mind, at least, of what is a collective mind. And what about our own mind? Is it only in our brain? We know that bodies and brains communicate, but coming back to our first question, does this influence healing? And does this influence behavior and intelligence? Some clues are coming from the growing science of psychoneuroimmunology that shows that the separation of brain and body are artificial. There are places in the brain where this communication takes place, as we see on the left. But the communication is two-way, as we see on the right. The brain, when it is stressed, emotionally inhibits the immune system. But when the immune system is fighting a cold, it tells the brain to take the day off and lie down. I'd like to let some scientists and researchers chime into this discussion. So please watch these next 2 videos. My Stroke of Insight by Jill Bolte Taylor is absolutely fascinating about the right brain. And Coping with Stress, the truth behind psychoneuroimmunology. Watch at least the first 30 minutes, which is where she introduces psychoneuroimmunology. We'll be talking about the stress part in our next unit, in 2 units from now. And we'll see you in the next module in this unit. Thank you.